So how do you achieve high availability with RMQ clusters? In a RMQ cluster, exchanges and the configuration information such as user logins are replicated across all nodes. So each node can be declared as a disk back node or a memory back node, and that just means where the exchange configuration information are stored. So in the disk back node, it actually stores it to the hard drive or SSD. In that case, when it comes up, you can read that information from there. So in a MQ cluster, you must have at least one disk back node, because if the whole system goes down and you have to bring back all the nodes, then at least one node has that information. The other nodes can also be memory back nodes. And the reason why you want to use memory back nodes is because memory only nodes are much faster at replicating the data, because whenever you change some information, such as you declare a new exchange or you update an exchange, that information has to be propagated to all nodes before the operation can succeed. The other thing that you need to do in order to achieve high availability is that you will need to set up some high availability queues, which also known as mirror queues. And this is different than the regular queues. One thing that you need to know is that regular message queues reside on the node that is declared or created on. So when you create a regular queue, that queue is only attached to that node that is created on unless it's a mirror queue or high availability queue. The reason why you'll want to use regular queues is that it's also faster performance and you can achieve a higher message throughput. Sometimes you don't need a high availability queue. Like for example, you can have anonymous queues, which are very temporary, and also like any queue that behaves like a temporary queue where you create it, you listen for some response results, and then you dispose of it right after you finish it. So in those cases, you don't need to have those queues be highly available because those are very time sensitive and time limited queues. So high availability queues basically duplicate messages across all nodes, and that also has some implications that you need to be aware of. First is slower performance, and also it has a lower message throughput, because every time that you send a message to Rabbit, if it's targeted toward a mirror queue or high availability queue, it actually has to replicate that message across all nodes before the operation can succeed. So that means the throughput of the system depends on the throughput of all the different nodes within your system. But the trade-off is that it's more reliable, because now you have a copy of the message across all different nodes. And if one node goes down, then the other node still has a copy of that message. Whereas the regular message queues, you can only access those message queues when the node becomes available again. So for the regular message queues, if that message queue still has messages and that message queue is declared as durable, those messages are saved to the hard drive or SSD, but you can only access those data when the node becomes available again. So if a node crashes, you have to bring it back up, and then you have to connect back to the same node in order to access that information in those queues. So let's take a look at what happens when an high availability queue recovers. Mainly what happens when a new node comes in or a node that went down came back online. So when a new node comes online, it basically creates a mirror queue, but it is empty. So what happens with that empty queue? So you have two choices. One is you can leave it empty, and this is basically what they mean by a manual sync mode. Or you can have it mirror the existing nodes. But the downside is that while data is being copied from the existing node to the new node, the whole cluster becomes unavailable because of that syncing operation. So there's two modes that you can declare HAQ with. You can have a manual sync mode, which basically leaves the queue empty, and then basically every new message that comes in will get copied to the new node. But then the new node is not really a replica of the existing nodes. So over time, that new node will have the same data as the existing nodes because of the dequeuing operations and queuing operations of that queue. The opposite of a manual sync mode is to have an automatic sync mode, and what that means is that when a new node comes in, basically the whole cluster will pause for some time in order for the new node to copy all the data that's from the existing node, only for the high availability queues. So that can block most of your operations. And depending on your circumstance, I would say that you should have an automatic sync mode, because if you have a manual sync mode, there can be a window of time that your whole system is not highly available, because only certain nodes have certain data, and it's not replicated across all the different nodes.